Hi everyone, welcome to Python Code Nemesis. Today we'll be looking at understanding dependency injections with Python and also how to use repository functions and a repository layer in your, let's say, project so that usually we can't test DB functions on pipelines because you don't have a Postgres access there. So you cannot be testing DB functions, but if you have this dependency injection design pattern with repository layer, you can implement the in-memory repository to test the working of these functions. So let's get started. Dependency injection is a design pattern used in software engineering that allows objects to be created with their dependencies provided by an external source rather than having to create those dependencies themselves. In other words, instead of class creating its own dependencies, the dependencies are injected into the class from outside, which again we read about in the previous video. So if you haven't watched the previous video on dependency injection design patterns, domain-driven design patterns, please go and watch it. Why do we use dependency injections? The benefits of dependency injection includes increased flexibility, modularity in software design, improved testability, and reduced coupling between components. By decoupling objects from their dependencies, changes can be made more easily without affecting other parts of the system. For example, let's say we have a class that depends on a database connection. If we create the database connection within the class, we create a tight coupling between the class and the database. This means any changes to the database connection will require changes to the class, making the code less flexible and harder to maintain. With dependency injection, we can pass the database connection to the class from outside, making the code more modular and easy to test. This also allows us to swap out the database connections with a different implementation, such as one that interacts with the different database or an external API without having to modify the class itself. Implementing dependency injections in Python. Python is a very popular programming language and it supports several methods for implementing dependency injections. In this tutorial, we will use the constructor injection to demonstrate this concept. Constructor injection involves passing dependencies to a class through its constructor. This allows the class to store the dependencies as instance variables, making them available to its methods. Let's create an example to see how this works. We'll start by defining a user service that depends on a user repository interface. Class user service, def init self, user repository, self.user repository equal to user repository, def get user, which takes in self and user ID, return self.user repository.get user of user ID. In this example, the user service class takes a user repository object as a parameter in its constructor. It then stores the user repository object as an instance variable and uses it in its getUser method. We can define the user repository interface by adding a getUser method to it. Class user repository def getUser self user ID raise not implemented error. This creates a simple interface that any implementation of the user repository class must implement. In this case, we'll create an implementation of the user repository class called in-memory user repository, which stores user data in memory. So the init function creates a user's dictionary with 1, 2, and 3 as IDs and the name as Alice, Bob, and Charlie. And there's a getUser function which takes in self and user ID and returns self.users.get user ID, none. In the in-memory user repository class, we define a dictionary that contains user data and we implement the getUser method to retrieve a user by their ID. Finally, in the main function, we create an instance of the in-memory user repository and pass it to the constructor of user service. We then call the getUser method on the user service instance to retrieve a user by their ID. if name equal to main, then user repository is in-memory user repository, user service is user service of this object that we just created, and user equal to user service or get user of file. In this example, we created an instance of the in-memory user repository which implements the user repository interface. We then create an instance of user service passing in the in-memory user repository instance as an argument to the constructor. Finally, we call the getUser method on the user service instance to retrieve a user by their ID. By using constructor injection, we can easily swap out the implementation of user repository with a different implementation, such as that one interacts with a database or an external API without having to modify the user service class itself. This makes our code more flexible and easier to maintain. So, in case you had a in case you implemented this method in a Postgres database and you are connected to it, in that case, you just have to initialize like Postgres user repository and just pass that in to get this. So that's very easy. Not much changes required. By using constructor injection, we can easily swap out the implementation of the user repository with a different implementation. This is the complete in-memory user repository file. So from user repository, import user repository. From user service, import user server. Then in-memory user repository inherits from user repository, initialize set of users, get the user by their ID, and here use this user service to get this. There's a demo that shows how to swap out the in-memory user repository implementation with the actual database user repository implementation. So here we create another class database user repository which inherits from user repository. So this getUser function must be implemented, otherwise it will throw an error. So with SQLite tree.connect self.dbpath as connection, execute select ID from users where ID equal to user ID. And if there is a row, then return that row as ID row of 0, name row of 1, and if it is none, then return none. So initialize the DB directory, create that directory, create that, like join that path and create that path, call testdb, then in SQLite 3, make a cursor object with connection.cursor and execute these raw SQL queries, which is create a table with all users with 3 columns, ID as integer, which is the primary key, and name as text. 2 columns, sorry. ID, which is integer, and the primary key, and the name is text. Then execute insert into users, ID, name, values, 1, Alice, 2, Bob, and 3, Charlie. So user repository equal to database user repository, DB path, user service, user repository, and user service dot get user of 1. Print user of name. So you get to the user by the ID. In this example, the OS module is used to create a new directory called test in the current working directory if it doesn't already exist, and the path to the SQLite database file is created by joining the directory path and the file name testdb. Then a connection to the database is established. The users table is created here. This one. And some test data is inserted into the table. And finally, an instance of the database user repository is created with dbpath as argument, set to the path of the test database file, and this instance is used to create so this was connected to this dbpath. So finally, an instance of the database user repository class is created with the dbpath argument is set to the test database file, and this instance is used to create an instance of the user service class. The getUser method of the user service class is then called with an argument of 1, and the name of the user with an ID 1 is printed to the console. All the code for this article is available on GitHub, so definitely go ahead and check it out. So dependency injection is a powerful design pattern that can help make software more modular, flexible, and easier to test. Python provides several methods for implementing dependency injection, including constructor injection, which we demonstrated in this tutorial. By using dependency injection, we can create classes that are decoupled from their dependencies, making it easier to modify and maintain our code. This can also improve the overall quality of our software and make it more resilient over time. Right, so thanks for watching, and feel free to leave any comments on this tutorial. And don't forget to like and subscribe. Thank you. Happy coding.